Welcome to Power Electronics Education Electronic Book. Tutorial 1 Introduction. This tutorial is presented by Dr. Firuzare. So in this case, let's start with the power supply and the load. We have a PV system here, which basically generate DC voltage. And the point is that this DC voltage fluctuates because this voltage is not regulated as the sunlight is changed over the day. So this is our PV. The second supply is wind generator. Suppose that we have a generator and is connected to windmill, wind turbine, and this generator generate AC voltage and frequency and voltage fluctuate. The reason is that speed of wind is not constant, and the last power supply is battery, and we need this battery as a backup in a case that we have no wind or no sunlight. Then we need to actually provide power for some of the loads. So this one actually gives DC voltage. So if you look at the load in an isolated area, so basically we may have different types of loads, such as home appliances, TVs, and so on. Or in commercial, we may have different types of loads, for example air conditions or pumps. So we call that one load 1, load 2, and load 3. So it can be, for example, AC. We need to have AC line at 240 and 50 Hertz. So the point is that then we can provide energy and power for these types of loads. So the case is that how to transfer and extract power from these sources into the power system. So the case is that we have different types of power converters. For example, we have AC to DC, we have DC to AC, and we have also DC to DC. So think about it for 5-10 minutes and try to connect one of these power converters between the source and load and try to find the power electronic system for this configuration. So let's concentrate on the AC side. Suppose this is the load, which consists of load 1, 2, 3. We need to generate AC voltage at 240 and 50 Hertz. That means this voltage is AC. So basically we can have one power converter based on DC to AC converter, and the voltage can be at that voltage level and at that frequency. But the point is that because the output voltage is based on pulse pattern, so in real time we have PWM output voltage. So this type of voltage in real time is not suitable for different applications. So that's why in this case we need to have a filter. So in this case we need to have a filter, and the output voltage can be sine wave with little bit harmonics, and the harmonic level depends on this type of filter. So in this case we have a DC voltage coming from other sources, for example PV, wind turbine and battery, and in this case we need to generate a regulated DC voltage, for example at 400 volts, suitable for this main DC AC converter. Now let's concentrate on input side. The first power supply is a PV system. So we know that the voltage, output voltage from this PV is DC, and this DC voltage fluctuates. So we need to regulate that one. So in this case we need basically one DC to DC converter. So what we get here, we can also boost the voltage and regulate the output voltage. So the output voltage here is regulated, and for example we can get 400 volts here, suitable for the main DC to AC converter. So the second type of power supply is a wind turbine. So we know that the output voltage here fluctuates because of wind speed. So one possibility is that we can use, for example, AC to DC converter. That means if the frequency and voltage fluctuates, here we get DC voltage, and this DC voltage is not, the voltage across this output is not regulated. So another possibility is we can use, for example, DC to DC converter again. That means we can regulate this voltage, and here we can get same voltage as this voltage level. That means we can design this converter in such a case to get 400 volts. And the last power supply, which is basically we can use it as a backup, is a battery. So if the battery's voltage is lower than 400 volts, so we can use another DC-DC converter here to convert the low voltage into high voltage. So here we can regulate the voltage and get 400 volts. We can connect these outputs to this common DC bus, and this common DC bus is 400 volts. Now let's look at the power flow. For a DC system, for example for this PV system, so we need to actually extract the power and transfer it to the DC side. So this case is unidirectional. But in wind turbine, if we use AC-DC converter, the point is that if we use based on diode rectifier, so in this case is unidirectional. But for example in different applications, for example if we have induction generator, we need to deliver reactive power to the wind turbine, otherwise we are not able to generate voltage at the output of this generator. So in this case it's not possible to use AC-DC based on diode rectifier, but we need to have active AC to DC converter, which is basically one type of DC AC converter. That means if we design AC DC and look at the input from this side, so here you can see that this converter is DC to AC for this terminal, and basically in this case, if we have an inductor and if we control this current and if we control the magnitude of current here, that means we can control the power. So with respect to this terminal at any phase angle, so it's possible to control the active and reactive power. So in this case, even instead of this AC-DC based on diode rectifier or DC-DC, we can use active AC to DC converter. Battery, in this case, we use this power as a backup. We have to transfer the power into the DC line, but the point is that when we have significant power coming from PV and wind turbine, then we should be able to charge the battery. So that's why in this case it's quite important to design a power converter here, DC-DC, which should be bidirectional. That means charging, this is the power flow, discharging, this is the power flow. So finally, this is the power system. That means for these three different types of loads, load 1, 2, and 3, these are connected to this AC system, which is basically 240 volts and 50 hertz through this filter, output filter, and this filter is basically connected to a high power DC to AC, and the voltage at this terminal is, for example, 400 volts. And if you look at the PV system, this PV is connected to a DC-DC converter, so if this is 400 DC bus, that means this one is connected to 400 volt and that voltage is regulated. Wind turbine, so this turbine, we can connect it through, for example, AC-DC. If it's active, then we can connect it directly to 400 volts, or otherwise we can use based on diode rectifier. That means AC-DC, and then we can regulate through DC-DC converter. And the last one is a battery, and this battery is basically connected through DC-DC converter. So if we define the polarity, for example, plus minus, and we can also define it here, and this one, the output voltage is connected to, this is a power electronic system for a hybrid power system. So what's the power electronic system use an AC motor drive? So let's look at the block diagram. So if this is the AC voltage, so the point is that this voltage is regulated because it's coming from grid 420 and 50 Hertz. And if we have AC machine, so we need to control the speed. To control the speed, we may control the frequency and voltage. So in this case, we need to convert the AC from this supply into another AC with variable frequency and variable voltage. So the point is that what sort of power electronic system we need to design and use for this application. So we have four types of converters: DC-DC, DC-AC, AC-DC, and AC-AC. So think about it for 5-10 minutes and then design the power converter. So let's start with low power AC machine. So in this case, we may control speed by changing the input voltage magnitude. So if we have AC voltage from grid at that voltage level and 50 Hertz, so that means this is the voltage waveform. So one possibility is to control the speed is using AC-AC converter. Based on thyristor or SCR. So in this case, we can control the firing angle and then we can generate this voltage. So the point is that by controlling the firing angle, the case is that we can control the output voltage. So we can control the RMS and magnitude of output voltage, but the point is that frequency is constant. Still frequency is 50 Hertz. So this type of converter, this type of motor drive is very simple and cheap, but the case is that is not suitable for high power AC drive system. So in this case, we need to change the topology. So for high power converter, so if the input voltage is AC grid voltage, so higher power converter can be used for high power drive system. So one possibility is AC-DC converter based on diode rectifier. That means the output voltage is unregulated. And then if we use a capacitor here, then we get DC voltage. And then we can connect it to another power converter, which is basically DC to AC. So here, by controlling the converter, we can even generate single phase or three phase, controlling the frequency and magnitude. Then we can connect it to different types of AC machine to control the frequency, to control the speed. So in this case, this type of converter basically is designed based on this type of switch. That means IGBT. With the diode. This converter operates at high switching frequency. while this one operates at line frequency. So this is the power converter for AC drive system, and in this case, in most of applications we don't need a filter. That means we can directly connect it to either single phase or three phase machine. But for some applications, especially if there is a long cable which may resonate and create over voltage, then we may need to have a filter between the drive and the AC machine.